In this video, we want to look at the electronic structure of atom. And under that, the first thing we want to consider is the electromagnetic radiation, that's EMR, different from electronic medical record. So this one means electromagnetic radiation. Okay, let's define what electromagnetic radiation is. And we say that it is the propagation of energy in a waveform with periodic change in electric and magnetic fields. So having defined that, let's look at the characteristics. One of the characteristics is that EMR has wavelength. We use lambda to denote it. Now, wavelength is the distance between two successive crests. If we have this go like this and on and on. This is a crest, this is a crest. So the distance between two successive crests is known as a wavelength. Okay. It is also the distance, it is also known as the distance between adjacent corresponding part of a wave. So the next one, it is different from wave number. So let's look at wave number. Wave number actually is the reciprocal of wavelength. So we use 1 over lambda for it. The SI unit for wavelength is meters, and then that means the SI unit for wave number is per meter because of 1 over, so per meter. So we can just define this as the reciprocal of wavelength. Okay, so we say that this is equal to 1 over wavelength. Okay, another characteristics is frequency. A wave has frequency. So we use either F or V to denote it. So it is the number of wave or cycle per second. That's this. Another one is velocity. We use C to denote it. This is the speed of a wave. We represent it by the speed of light, and that speed of light is 2.998 times 10 raised to power 8 meters per second. But most times it is approximated as 3.0 times 10 raised to power 8 meters per second. So anyone that you are given in a question, that's the one you will use. In most cases, the examiner uses this. That's the second one. So it is the speed at which a wave moves. Now, there are some things we need to note. That energy is given as HF, which is also given as mc squared. Now, this is Planck's constant, this is frequency, and or this is mass, this is speed of light. So while this is energy. So since this, it means that HF is equal to mc squared. So, but F on its own is equal to C, that's speed, over lambda. So if we bring this, we can call this, let's name them equation 1, we can call this equation 2. So if we are to bring that F is equal to this, and we can introduce it here, we can now say that HC, because instead of writing F, we replace it with this, over lambda. This is F over lambda is now equal to mc squared. Now 1c can remove 1c here. What you have left is that h over lambda is equal to mc. So from here, we can make lambda subject of the formula. If we make lambda subject of the formula, lambda becomes h over mc. So this is for radiation. Then lambda is also equal to h over mv. This is for linear speed. Okay, let's look at this question. It says A radio station broadcasts at frequency of 1.09 times 10 raised to the power 8 per second. Determine the wavelength. Also, the energy associated with radio frequency and wave number. We are given Planck constant to be 6.626 times 10 raised to the power minus 34 joules second. Then the speed of light is 2.998 times 10 raised to the power 8. Okay, now for us to solve, we need to first of all note the first one is to determine wavelength. What's the relationship between wavelength, frequency, and speed that is given to us? We know that frequency f is given as speed over wavelength. If we make wavelength subject of the formula, we will have that wavelength is equal to speed over frequency. And if we plug in the value, we're going to have 2.998 times 10 raised to power 8 divided by 1.09 times 10 raised to power 8. So if we divide that, what we're going to have is about 2.7505 meters. That's the wavelength. The next one is the energy that is associated. Now we have a relationship that E is equal to HF, Planck constant and frequency. The H, Planck constant given to us is 6.626 times 10 raised to power minus 34 times the frequency that we want to use, which is 1.09 times 10 raised to power 8. And if we multiply that, we're going to get that the energy is 722.3, okay, 0.234 times 10 raised to power minus 28 joules. All right. Then the next question there is wave number. So for us to get the wave number is 1 over lambda, 1 over wavelength, which is 1 over our wavelength that we got was this. So 1 over 2.7505. So what we're going to get, if we do get that, will be 0.3636 meters. Now, another question, it says calculate the frequency and energy of a microwave with a wavelength of 3.60 centimeters. Now, the first thing we need to know is that the appropriate unit to use is not centimeter. The appropriate unit to use is actually meters. So converting from centimeters to meters is actually dividing by 100. So we say 3.60 centimeters is equal to 3, and a more appropriate way to do that will be 60 times 10 raised to power minus 2. So meters, so we use is now in meters divided by 100. So remember, what we're asked to calculate first is frequency, and we said that frequency is speed over wavelength, and speed is a constant, which is 2.998. Remember I said if you were given 3.0 times 10 raised to power 8, please you use that. So just for the sake of this video, we're using 2.998 times 10 raised to power 8 meters per second. So here we'll now use 3.6 times 10 raised to power minus 2. There's no really need for writing the 0 again. So if we divide that, what we're going to have is that frequency actually is 8.320 times 10 raised to power 9 per second. Now, the next is to get the energy. Energy is given as Planck constant times frequency. So the Planck constant is 6.626 times 10 raised to power minus 34 times the frequency this time around, which is 8.320 times 10 raised to power 9. If we multiply both of them, we'll have that energy is equal to 5.518 times 10 raised to power minus 24 joules. So like the video, subscribe to this channel by clicking the subscribe button, You can also click the notification button so that you can get new notifications of new videos. Thank you. Share the video to your friends.